Morning, everyone. Today, we're going to tackle about the invention of machine and their effects on theoretical mechanics and other scientific studies. I am Madrigal Jade Barbie, your presenter for today. Let's start with the German-Dutch spectacle maker Hans Lippershey. Hans Lippershey was born in 1517 in Basel, Germany. It is not exactly known where he got an idea for building his first telescope. Some says that he heard a similar device that were made by other people, while some believes that he simply came to idea to it when he saw children playing with lenses. In any case, in 1608, he managed to create his first crude telescope that had either two convex lenses and a concave eyepiece lens. The design was brought to the State General of the Netherlands so it can be patented, but there Leprosy encountered the problems. Because many people made a similar device, he was not awarded a patent, but he received generous reward by Dutch government. The same year, his design spread across Europe, enabling scientists to copy his design and start thinking about applying significant improvements. Leprosky's telescope had a modest 3 times magnification and called it Kijker, which means looker. The next is Cornelis Jubbel, a Dutch engineer and inventor. Cornelis Jubbel was born in Alkmaar, Holland in 1572. Around 1620, when he built his first navigatable submarine, while working for the English Royal Navy, using William Burney's design from 1578, he manufactured a steerable submarine with a leather-covered wooden frame. Between 1620 and 1624, Jubal successfully built and tested two more submarines, each one bigger than the last. The final model has 6 oars and could carry 16 passengers. This model was demonstrated by King James I in person and several thousand people in London. The slide rule. The slide rule was invented by the English mathematician and Anglican clergyman William Ogthred, who was born on March 5, 1574. After John Napier invented logarithms and Edmond Gunter created logarithmic scales, upon which the slide scale are based. It was Ogthred who first used two such scales sliding by one another to perform direct multiplication and division, and he is credited as the inventor of the slide rule in 1622. The purpose of this slide rule is to read the distance relationship, thus multiplying and dividing directly. Though the slide rule was invented in 1600s, it was only begun to be widely used in the mid 1800s after a French artillery officer named Amédée Manhin developed a version that became popular among engineers. Steam turbine. Steam turbine was invented by Giovanni Branca, an Italian engineer and architect. He invented steam turbine in 1629. Branca's steam engine has a wheel with flat vanes like a paddle wheel, shown being related by steam produced in a closed vessel and directed at the vanes through a pipe. He suggested that it might be used for powering pestles and mortars, grinding machines, rising water, and saving woods. Micrometer screw gauge. Micrometer screw gauge was invented by William Gascoigne in 1636. In the 17th century, William Gascoigne the first micrometric screw as an improvement of the vernier. It was used in a telescope to measure angular distance between stars and relative sizes of celestial objects. It is used also in the mechanical engineering field for measuring extremely small dimension. Adding machine. Adding machine was invented by Blaise Pascal. Blaise Pascal was considered a child prodigy and was gifted in a variety of areas including mathematics, philosophy, and theology. Pascal's father, Etienne, held a position calculating taxes. He was often overwhelmed with work. He and his helpers were often up late figuring tax levies using manual calculators and an abacus. So in 1642, the young Blaise Pascal designed a calculating machine to help speed up the process. The Pascaline, or the adding machine, is the first mechanical and automatic calculator. It represents the position of digits with the help of gears in it. The machine is sometimes called adding machine or Pascal's calculator. Mercury barometer. The first mercury-filled glass tube was generally accepted to have been invented in 1643 by Torricelli, which became known as Torricelli's mercury barometer. In this, he produced a vacuum by filling a glass tube with mercury, inverting it, and then submerging the open end in a vessel of mercury. Pendulum clock. In 1656, Dutch mathematician, astronomer, physicist, and horologist Christian Huygens invented the pendulum clock in 1656 and patented it in 1657. This technology reduced the time of loss by clocks from about 15 minutes to about 15 seconds per day. Hygiene contracted the construction of his clock's designs to clockmaker Salomon Coster, who actually built the clock. Hygiene was inspired by investigations of pendulums by Galileo Galilei. Reflecting telescope. Reflecting telescope was invented by James Gregory, an educated at Marischal College in Aberdeen. He studied optics and telescope construction and in 1657 wrote Optica Promota or the Advance of Optics. In it, he described the first practical reflecting telescope. The primary mirror in reflecting telescope refracts the light back up towards a smaller secondary mirror located some way up the barrel, which in turn reflects the light back down through a small aperture in the primary mirror, where it is then brought into the focus by the eyepiece lens. The Gregorian was designed to solve the problem of viewing the image in a reflector by allowing the observer to stand behind the primary mirror. Newtonian reflecting telescope. In the mid 1600s, Isaac Newton was studying light and found that the bands of colors, like in early astronomers, were formed from lights passing through a lens or a prism. He came to the conclusion that white light is really a mixture of light of different colors. When light passes through a prism, the different colors separate and are discernible. The same thing happens with the lens, but to a much lesser degree. Newton thought that it would be impossible to get rid of chromatic aberration as long as lenses are used in telescopes. The Newtonian telescope is different from the Gregorian in its placement of the eyepiece and the lack of a hole in its large concave mirror. Additionally, the Gregorian secondary and smaller mirror is also concave, whereas Newton's secondary mirror is flat and angled. Leibniz calculating machine, or a step reckoner. In 1671, the German mathematician and philosopher Gottfried Wilhelm von Leibniz designed a calculating machine called the step reckoner. It was first built in 1672. The, the step reckoner expanded on Pascal's ideas and did multiplication by repeated addition and shifting. Leibniz was a strong advocate of the binary system. Binary numbers are ideals for machines because they require only two digits, which can easily be represented by the on and off states of a switch. When computers become electronic, the binary system was particularly appropriate because of an electrical circuit is either on or off. This meant that on could be represented true, off could represent false, and the flow of current would directly represent the flow of logic. Leibniz was prescient in seeing the appropriateness of the binary system in calculating machine, but his machine did not use it. Instead, the step reckoner represented numbers in decimal form as position of 10 position dials. Even decimal representation was not given. Christian Huygens pocket watch. On October 4, 1675, prominent Dutch mathematician, physicist, astronomer, and inventor Christian Huygens patented a pocket watch. The watches, which were made in Paris from 1675 and following the Huygens plan, are notable for lacking a faucet for equalizing the mainspring torque. The application in that Huygens thought that his spiral spring would isochronize the balance in the same way that he thought that the cycloidally shaped suspension curves on his clock would isochronize the pendulum. All watches used in the same basic mechanism until the first quartz crystal oscillators were developed for watch in 1959. The universal joint. The universal joint was invented by the English polymath active as a scientist, natural philosopher, and an architect, Robert Hooke. A Hooke's joint or universal joint is a joint which connects two non-parallel shafts inclined at a small angle to help transmit motion between them. It is often used to transmit rotary motion between two non-parallel but intersecting shafts. Pressure cooker. The pressure cooker was invented on August 22, 1647 by French physicist, mathematician, and inventor Denis Papin. He is best known for his pioneering invention of a steam digester, the forerunner of the steam engine and the pressure cooker. He never built an effective working engine of his own, but his idea was improved by others and led to the development of the steam engine, a major contribution to the Industrial Revolution. The pressure cooker first appeared in 1679 as Papin's digester, named for its inventor, French-born physicist Denis Papin. The cooker heats water to reduce very hot steam, which forces the temperature inside the pot as high as 266 degrees Fahrenheit or 130 degrees Celsius, significantly higher than the maximum heat possible in an ordinary saucepan. Lastly, the steam pump. The first successful steam pump was patented by Thomas Savery in 1698, and in his words, provided an engine to raise water by fire. Savery's steam pump was a revolutionary method of pumping water, which solved the problem of mine drainage and made widespread public water supply practicable.